Okay. I have several lessons we're going to go through today, but this is my 19th year of teaching. I've been teaching in computer labs for 19 years, and I learned a super valuable lesson. Right now it looks like there might be 2 people who are actually focused on what I'm saying, and that doesn't work for me. So I've got this fancy little thing that I can do here. So now you have no choice but to focus on me. I can do that. Also, we'll go through the lesson that way. I'll project my screen onto yours. So there's not a lot of times that you have to look at me, which is, as far as I'm concerned, something that's very nice that I do as a teacher. But for the first little bit here, I just have several things I want to go through for housekeeping. I don't know how many people signed in yesterday and watched the live stream. I think the max viewers I had was 5, and there's 9 of you here right now. So it was definitely short of a few people. So I'm just going to go through that housekeeping stuff again real quick. First and foremost, we're in a super dangerous situation right now. Coming back into schools feels like, I don't know, if I just pick a random example off the top of my head, going to a rodeo in the middle of a pandemic. Just a giant rodeo. And just pretending like there isn't a pandemic. That's what I feel like it's kind of like. So we're going to stay away from each other. When you're here, you're at your workstation. There's no, normally I'd let students, if you're bored and you need to take a break, yeah, get up, walk around. For the meantime, we're not going to do that anymore. Okay? There's no reason for you to come back here. Realistically, I'm the most susceptible one in the room because I'm old. So stay away from me, and I made a little barrier so that you can't. I did get my vaccine yesterday, but it takes 2 weeks to work anyway, so there's no reason for you to come back here, and you'll see as we progress through this. Yesterday I had a student who asked me a couple questions, and I couldn't hear just because she wasn't loud enough. So I just said, can you just use Teams and just type your question into Teams, and then I can send you the message back, which seems a little bit ridiculous for us to communicate electronically when we're in the same room, but like I said, there is this pandemic thing going on in the world. So for the meantime, if you have a question, we're not in kindergarten anymore, so you don't have to put your hand up. Just say, Baron, and if I'm on my computer, I'm not, and I don't see you, then I'll look up and be like, oh, somebody needs my help. Cool. The other option is to just Teams me, but feel free to just start talking. Say, Baron, I don't understand this part, and then I will remotely look at your computer screen and figure out what the issue is. Okay? Looking back to, I think that's the majority of it. Oh, if there's a fire drill, there's not going to be a fire drill. If there's a real fire in this fully brick building, if it starts on fire, okay, I don't know how hot it has to be for brick to burn, but I'm guessing if you're in a building where the brick is on fire, having an exit is not really going to be a big important thing. But if the fire alarm goes off and we need to bail, we go out these doors, turn left, and go down this stairway right here, and we go out those doors right there. And we'll meet at one of those big trees outside, okay? I have to cover that. I think that's the stuff that I want you to see there. Let's go back to our computer screens here. You should see my screen. So, leaving the class. I'm a big proponent, if you remember my first day PowerPoint, I'm a big proponent of allowing students to show us they can be independent, but I have to track every time you leave the classroom. So you click on this thing here. Whoops. You click on this thing right here. It's a questionnaire. You have to answer the questions. What period is it? Obviously, it's going to be 1. You're going out. Bathroom. Then you submit your answer, and then when you come back, you fill out, I'm coming in, and submit the answer. Okay? Please remember to do that before you leave and when you come back. Please let me know that you are in fact leaving. Okay, so don't just bail. Teams meet, just say, Baron, can I go to the bathroom? I'll say, have you filled out the form? Then you fill it out, and you're good to go. Okay, and that's right at the top of my Moodle page. It's the second thing under my live stream. It's the virtual hall pass. Okay? Anytime you leave the classroom, whether you get called down to the office, whatever it is, you have to fill that out. Okay. I think that's the majority of it. Now, like I said earlier, I didn't know how many people tuned into the live stream. That is your responsibility to check in on that every day you're not here. So, did you log in on one of those computers? Yeah. Okay, I want everybody anywhere but those 4 computers.
Oh, that's what you said. My bad.
Yeah, no, it's okay. Just leave it for now. We'll just get you to bump over once I'm done, okay? It's good. Stay right there now because then you can still follow along. Okay? I use those 4 for tests and stuff. So, okay, where was I? You've got to log in when you're at home every day. Now, you're going to see that there's going to be times where you don't have to because you'll be on a 2 or 3 period programming coding assignment. So tomorrow you're not going to have to log into a live stream. There won't be one tomorrow because you're going to be working on your proficiency project. But yesterday you should have logged in. Now, I know people didn't, so there's no need to panic. If you come onto my main page here and you find my YouTube channel, okay, in my YouTube channel, so if you just click on this spot here, it's going to take you to today's live stream. There should be some echoing happening now. But if you, yeah, it's live, okay. So if you come to this spot right here, you can just click on my name, and you can see all my videos, okay? You can go to my playlists, and you can find Computer Science 20. Now, it happens to be right here. Okay, so you can see all my playlists, Computer Science 30, Computer Science 20. I went a little crazy during the original quarantine back in March, like 2 Marches ago, and I made some videos. They're really bad, but if you want to watch them, they're funny because it's bad. Like funny, like at, laughing at, not with. I'm fine with that. I got a bunch of stuff here you can look at. So if you go to Computer Science 20, these lessons should all be in here, okay? So these are lessons from further on. You want to look for the current lesson that you're working on. So yesterday you weren't on the live stream, which was, I think it was strings and scratch. Yeah, lesson number 4. So you come in here and you say, where's lesson 4? Oh, here it is, lesson 4, strings and scratch. That's 30 minutes long, but a lot of that, like I started it early, so the announcements were on there, a couple other things. So you can just go in there, take a look, scroll through the things that you need to get to, and then you don't have to be in it for the full 30 minutes. Okay? So, for example, I haven't even started the lesson today, and we're already 8 minutes in. So that's where you'll go if you happen to miss it. If you aren't able to check in tomorrow, and you have or maybe you have a spare in second, and you just don't want to get up early. That works for me. As long as you get the work done, what does it matter? Okay? So that's how you access that. All right. So moving forward here, this Strings for Bible Stories is one I said should have been done yesterday. Okay? Oh, I'm going to change myself back to a teacher. So Strings for Bible Stories should have been done yesterday, May 3rd. Okay? So today, if you look, we have 1, 2, 3 lessons in a row. So I'm going to go through all 3. They're not as long as the other lessons are altogether. They're probably really 1 lesson. I don't know why I broke them into 3, but I'm going to go through those 3, and then we're going to work on assignment number 7, Scratch Proficiency. All right? So starting with lesson number 5, Boolean Blocks. Okay? A Boolean block is a hexagonal block, and it fits into any of the hexagonal spots. All Boolean means is true or false. Okay? And if you remember computers, everything is 1s or 0s. So true or false can get simplified even more to say 1 or 0. A 1 is true, a 0 is false. That's it. That's basically the building blocks of every computing system until you start getting to things like quantum computers and things like that. Okay, so with a Boolean block, you're going to have something that checks it. So you're going to create a statement, and then you're going to check it. So, for example, out of all those statements at the beginning in that practice assignment I had you do to start the year, I never actually returned to that one, but if I say, Mr. Barron, I can't even remember what they were now. I think Mr. Barron had a puppy named Cuddles when he was growing up. If you check that statement was true. So it would return a 1. Okay, it would return a 1, it would return a true. It would carry out whatever actions need to be carried out if that statement was true. The Hamilton Tiger Cats contacted Mr. Barron after his university football. Again, that one was true. Okay, Mr. Barron was an extra in the movie Just Friends. That one would return false. Okay, that one was the false one. So out of those statements, the Boolean on each of them returns true or false, and that's what's going to happen here. And lots of people think, wow, big deal, true, false, what can you do with that? Well, there's actually lots you can do with it, because you can also add this little not at the beginning of it. So when something is not true, then I want you to carry out this action. Okay, these are all the blocks that you can use. We're going to go through them. Okay, good. There's a bunch of stuff here. Rather than go through these screenshots, I'm going to open up my Lesson 5 stuff, my Lesson 5 program, and I'll actually go through real-world examples of them. Here we go. Okay. So, which one's first? We're going to go with if the space key is jumped, broadcast. Okay. Touching Sprite. All right. Okay, so this one right here, I have this cat selected. You can see by the Sprite I have here, this cat is selected. And this is the code blocks I have associated. So when the program starts, forever say whether or not this thing is touching the Yeti. Okay, so here is our Boolean. Okay, what did I say? Hexagonal? 1, 2, 3, 4. Is hexagon 6? Morning. Just grab a spot anywhere but these 4 computers and try and grab somewhere where you're at least 1 computer away from someone. Perfect. Okay, so is hexagon 6? Yeah? Okay, good. Okay, I'm bad at math. That's the hexagon. This is your Boolean. Okay, this is your true or false statement. So what it's saying is the Sprite that this code is attached to touching the Yeti? And I can pick anything. I can pick the mouse pointer. I can pick the edge. I can pick the fly. I don't know what the fly is. I can pick the bat. I can pick the bear. Anything. That's the Boolean. Is it true or is it false? All right, so I take this Boolean and I want it to tell me whether or not it's touching. Okay, so if it is touching, what string is the cat going to print? What string is the cat going to say? False? Okay, let's see. Because the other option would be what? True, but we know he's not touching, right? Or it's not touching. Okay, so if the cat's not touching, so we know it's false. This statement is false. What's the other thing it could report? Instead of saying false, it could say, remember how computers communicate with 2 numbers? 0. Who said it? Marvelous. Thank you. Okay, so it could report false or it could report 0. I actually forget. I can't remember. Okay, so I'm going to have this touch the Yeti, run the program. It says true. Okay, it says false. It says true. It says false. Okay, so it's reporting based on the string we want it to report on, not the actual value of a Boolean. Okay? Now, this forever loop, we're going to talk about loops as we go here. This forever loop's important because if you want something to constantly be going back and checking, so if you want it to happen gradually or later on in the program, you have to have that forever loop. If you just do this, when I run the program, it says false. It's still false now even though it's touching because it checked once and then it's stopped. It's not going to keep checking. All right, that's why you want to put this into a forever loop so that, and then I have to start it again, so that it can change and be ongoing. Okay, the next one. This one right here, forever say 3 plus touching Sprite 1. Now what I've done is I've forced the Boolean into math, okay? First of all, I have my forever loop, I have my string, I have my join right there. And if we remember back to these operators, these are all math. Okay, so this is where I got that one. These are all math. So if you put a Boolean, this is really great thing about Scratch, because to do this in other coding languages, it takes a fair amount of code, because you have to tell it what to do. The Scratch program just says, oh, you put a Boolean into a mathematical operation? Oh, okay, obviously you want us to report that Boolean as either a 1 or a 0. Okay, so I create the math equation that I want to say 3 plus true or false. 3 plus 0 or 3 plus 1, depending on whether or not the statement's true. I put it into my string block, into my forever loop, and I attach the whole thing. So now, we want to check the Boolean first. So is the flying sprite touching the Yeti? False. False has a value of 0. 3 plus 0 is 3. So when I run this program, it returns 3. Okay, it prints 3. If it's touching the Yeti, now it says 4. Because the value of the Boolean is changed to 1 instead of 0. 3 plus 1 is 4. Everybody with me? Relatively simple stuff. Okay, who's next? Let's go with the, okay. When the program is started, if the space key is pressed, then broadcast ouch. Okay, so when we worked on broadcast last time, a broadcast is just a message that kind of goes out to every sprite and the backdrop, it goes everywhere, so that I can use control or events like this one that says when I receive the ouch broadcast, say stop pushing the space bar, it hurts me for 1 second. Okay, so I run the program, oops, I push the space bar and it says that for 1 second, okay? So it checks this Boolean, is the space bar pressed? If it is pressed, it broadcasts ouch. If this one receives ouch, it says the string I have it saying here. Okay, the bear 2. This is basically the same thing. When the bear is touching the edge, so it checks the Boolean of, is this bear touching the edge? Okay, and when it is, say done for 2 seconds. If it's not touching the edge, there's no command given, so nothing happens. So this bear just sits here. Nothing happens. It's touching the edge, it says done. Okay, and the last one, the bat. Okay, this is the one that sometimes can be a little bit confusing. So we have a comparison happening here, and that's this one. Where'd it go? Right here. This one equal to this one. So we're going to check whether or not the two Booleans we put in there are equal. So right now this bat is saying leave me alone. Okay? So what it's asking is if the key down arrow is pressed equals the key up arrow is pressed, then say leave me alone. Now if you look over here, my hands are not on the keyboard. I'm not pushing the arrows, and it is returning a leave me alone. Okay? Because it's not returning whether or not they're true or false. It is returning that, but we're checking to see if they're equal. That's what's happening here. The green operator block is saying, hey, is whatever is in here equal to whatever's in here? And they are equal right now because they're both false. I'm not pushing the down arrow and I'm not pushing the up arrow. Both are false, Therefore, it carries out this command for leave me alone. And it's not going away because it keeps checking it over and over again, and neither one of them are pressed. Now, when I press the up arrow, it takes about a second, or whatever it is for the last time it ran, for it to check again and say, oh wait, the up arrow is being pushed. So this one returns false. This one returns true because I am pushing the up arrow. And this one returns false. Because it's inside this comparison block, this math operator, it's saying these two things have to be equal. Okay, go back in there. All right, so these two things have to be equal. The equal doesn't mean just positive. It means positive or negative. So when I push up, it goes away. If I push down as well, I'm pushing both of them at the same time. It comes back because now they're both returning true. Okay? Questions on that one? I believe that's the lesson in a nutshell. Mouse down, touching color. They're basically the same thing with different options. Okay. If there's no questions, for some reason my Teams is not opening. In case people who are watching at home have a question, give me 10 seconds to figure that out. Okay, Teams is opening now. 10 more seconds, then we'll be good. Okay, it doesn't look like there's any questions on computer science on Teams. So for those of you that are watching at home, if you have a question, please go into the Teams chat and ask it there. Okay, so we finished lesson 5 on Booleans. Lesson number 6 on if-then statements. These next two, they're relatively short. I talked a little bit about it yesterday, but an if-then statement is just a condition. If this condition is true, whatever condition you want to make is true, do this. If it's not true, do this, which is always something different. Okay? So if I'm hungry, I eat. Or, instead of saying or, you say else, I get sick or die. Whatever you want to say. Okay? That's a basic if-then statement. Okay? So we're going to have a condition that we want to check. If the condition is true, it carries out the next line. If it's false, it carries out the following line on top of that. So going back into this and finding my lesson number 6, if then else. All I have is this cat. This should be deleted. Okay, let's change this. Slower. Okay, so when I click this button, I want my Sprite to go to spot -199 to 105. That's over here somewhere. And then I want it to repeat until the Sprite is touching the edge. If loudness is less than 30 decibels, then say, is greater than 30 decibels. I told you I was bad at math. If the loudness is greater than 30 decibels, say shut up for 2 seconds. Else, move 10 steps. Yes, question.
Are our screens supposed to be showing?
Yes, thank you for telling me. Did it switch? Oh, that's weird. Give me 1 second. Why did it reverse? Okay, so now the people at home are not going to have that view. Ha! Yes. Okay. Okay, I had to reverse my monitors. I don't know why I did that. I believe the live stream has Scratch as well as the classroom now. Okay, so for this block of code, it's going to say go to this spot to start, and then if do it until the sprite's touching the edge. If loudness is greater than 30, so all that's doing is checking the decibel level based on your microphone. So I don't think you'll be able to use these ones on the computers in the lab because they don't have internal microphones, but mine does, so I can use it. And you can see my loudness variable is jumping as I talk. Okay, so this is my Boolean loudness. Okay, whether it's greater than 30 is the condition it's checking. So is the decibels, the internal mic picking up greater than 30, or are they less than 30? If they are greater than 30, we're going to carry out this command. We're going to say this string. If it isn't, we're going to move 10 steps. But remember, it's going to move 10 steps, check again, move 10 steps, check again, move 10 steps, and it's going to do those checks in fractions of a second. Okay, so it's going to look like the cat's just moving across the screen at a pretty good pace because it checks that quick. So when I run this, I'm going to have to make noise in order to stop the cat from moving. So here we go. Stop! No, you shut up. Don't say that, it's mean. Okay, so that is how my Boolean is working with my if-then statement. We have if, then, else. Those are the three things included in an if-then statement. If you don't include an else, nothing happens if the condition is false, which is something that's not very good. Think about yourself when you use a program. If you play a video game or when you're using any program that you use, if you do something and nothing happens, that's probably the most damaging thing that can happen. Rather than the wrong thing happening, nothing happening is worse because now the user is so confused because they did something but nothing happened. You always have to have an else in case your condition's not true, just so that something reports back to the user. Okay, and you're going to hear me say this lots. The user's stupid. You have to prepare yourself for that. Yes, we use computers and play video games, and we understand how this stuff works a little bit better than the average person. But for the most part, create your programs like the user's stupid, because they're most likely going to be stupid. So always have an out for your if-then statement in case. Once we get into more advanced code, you can use different ways of providing multiple options. So you say if this, else this, if else, if else, if else, if else, and you put 15 different options in there. We're going to do that with a rock, paper, scissors program that we build once we get into Python. Okay, any questions about this one? If-then statement, as well as there's a loop in here. Okay, I believe that is the same stuff that I've created there. Yes, I'm going to go back to the last lesson for today, which is repeat blocks, which you've already seen in multiple spots. Okay, so lesson number 7. Okay, so this one says, this is our repeat block. Okay, they call it repeat blocks. In Python and Java, you're going to call them loops. Okay, so there's one loop. Here's our second loop. So we started with a forever loop so that it's always going to keep checking. And it's going to run this second loop. So what we're doing here is called nesting loops. We're putting loops inside of loops inside of loops. And you have to, when this starts to get confusing, you have to go back and check when the furthest inside loop, the deepest nested loop, when did that one terminate? That's what you want to try and establish. Okay, so with this program, here is my Boolean put inside of an operation. So my Boolean is mouse down. Right now, I'm not touching my mouse, so that is returning false. Okay, I'm not pushing the button. When I grab it to drag it here, that's returning true. Okay? Here's where it can get a little bit confusing because we're going to use a not statement. So a not statement is the opposite of what the actual condition is. So right now, this returns false because I'm not touching the mouse. When I put it inside here, this returns true because it's a negative. Okay, that's what the not is. Because I'm not touching the mouse, the statement is true. It's like me saying, hey, are you touching your mouse? And you saying, no. And me saying, good, you told the truth. That's true, because you're not touching your mouse. It seems stupid and backward, but it is an integral part of coding and understanding how coding works. So when I put this in as the condition it's going to check, it's not going to go to mouse pointer. So this sprite is not going to go to the mouse pointer until I'm pressing down on the mouse, on the keypad. Okay? So now I press it and it goes to wherever the mouse is. So the mouse is here, it jumps to there. Mouse is here, it jumps to there. Okay? It continues to do that over and over and over again. That is the nested loop inside of another loop. The ballerina is hidden. So let's show the ballerina. Let's hide the cat. When this is clicked, repeat 16 times. Wait 0.1 second and change the costume. So this is basic animation. If you look at the ballerina's costumes, you can see I have 4 different costumes for the ballerina. And this one is going to switch to the next costume. And that is look. And where's next costume? Next backdrop. Here it is. Next costume, next backdrop. You can put either one of them in there. So when I run this program, this sprite is going to wait 0.1 seconds and switch to the next costume, and it's going to do that 16 times. So it makes it look like she's moving. Okay? You could put a longer wait in there as well. So if we say 0.3 and we run it again, now she moves a little bit slower. Okay, and all it is shifting costumes from step to step on a repeat block for 16. Now if I put a forever block there, she just keeps dancing the whole time. Questions? Okay. No questions in there. The dog. Ooh, I got a bunch of stuff in here. Sorry, this one's disassembled. I think that's the way I want it. So what I'm going to have happen here is I want this to happen 100 times. I want the loop to start by waiting half a second. Then I want it to move 10 steps. Then I want to put in an if-then statement. If the dog is touching the edge, erase everything. Else, stamp it. Then it goes back up to the top of the loop. So it's going to come back up to here. It's going to wait 0.5 seconds. It's going to move 10 steps. It's going to check this condition. As long as the dog's not touching the edge, it's going to continue to stamp it, change the costume, start it over again. I hope it's going to work. Let's see. Okay, so leaving a stamp just kind of leaves a little version of whatever costume's on there. It stamps it onto the screen. It doesn't clone it, because you can clone them too, where it creates another copy of itself. This is just like a picture stamped onto the stage. And when it hits the edge, it erases all. It still carries through the loop because there's nothing saying stop carrying through the loop, except for this is going to repeat 100 times. Okay, makes sense? Questions about any of that? Anybody at home have a question? Okay, from here, that is the end of the Scratch unit. So we are going to do a Scratch proficiency project, which is very simple in the requirements, okay? I don't want to stifle your creativity, so I don't want to force you into making a program that I think you should make. So I'm going to leave it pretty much open. I want you to challenge yourself. It's worth the majority of the marks in this module, so make sure you're putting the time into it that you need to. What I say typically for this assignment is 4 to 5 hours is what I'm looking for. Now, I'm giving you until Friday to do that, so you have lots of time to do it, but I need to see it. When I look at the program, I will be able to, I know enough about Scratch that I can look at the program and say, oh yeah, they spent some time on this. If there's 4 sprites with 2 costumes and like 1 block of code on each one, I'm going to know, okay? So I'm expecting you to spend 4 or 5 hours on this. If you want to spend a little bit more, that's okay too, but don't go too far into creating the next Flappy Birds. Just get something done that you can get through within those, 4 to 6 hours at best, okay? The requirements for the project, and it can be anything. It could be a game, it could be a story, it could be anything, whatever you want it to be. You have to use the skills that were taught in lessons 5 to 7. So those are the ones I just went through. Then you have to put comments in showing me where you use something from lesson 5 to 7. So you add a comment here that says, or whatever it is. Make the marking easy on yourself. If you have everything highlighted, there's absolutely no way for me to take a mark off. If you have a comment that says, hey, here's this part. Hey, Baron, here's this part. Hey, Baron, here's this part. There's no way for me to be able to go in there and say, oh, they didn't include everything. If you don't do that, I probably won't miss it, but there's a pretty good chance I'll go in and look and be like, oh, yeah, there's nothing here from lesson 5. Okay, so highlight it with the comments, make sure I can see it. And the last one is just well-designed logical use of programming skills. So your program fits together properly. You're not creating gravity by using 40 commands one after the other. You're using a repeat forever loop to do that. Okay, that's what I expect for assignment 7, Scratch Proficiency. Like I said, this is the last project in Scratch. We're going to move on to some other stuff after this. So make sure you're putting everything that you know into this one. And it's completely fine if you already handed something else in, say for your show me variables assignment, and you liked it, and you want to do something just a little bit more with it, go for it. Carry on with that project and just add more to it to make it fit the requirements of this assignment. Okay, I've put the due date in this one as Friday, May 7th. Okay, so that one will be due at the end of class Friday. On Monday, we're moving on to new content. Easy? Questions? The inside of my mask is soaked because I've been talking into it the whole time. Last chance, no questions at all. If you have some, please go into the Teams or just yell at me and say, hey, Baron, I have a question. That is all. So for those of you at home, that's it for today. There isn't going to be a lesson tomorrow because you're going to be working on this project. So please and thank you. Do a good job and have a wonderful day.